Now let us visualize the differentiation of a trigonometric function using a Riemann integration strips. In our previous discussions, we concluded that delta y of the Riemann integration strips is proportional to dy by dx. Just by taking the delta y, so we can find out the slope, which will be giving the differentiation form. So these are all the standard functions for which we are going to do the visualization. So we are going to do it for sin x, cos x, tan x, e power x, and log x. So first, we know that differentiation of sin x. So we know that it is cos x. Okay, and for visualizing this, okay, so this is the sin x function. Okay, this is the sin x function, and under which we have given the Riemann integration strips. So there we can find out what is delta y. So here you can place the delta y. You can find that the delta y initially it is maximum, and it goes on decreasing, and this becomes 0 at this point. So that is what we have it as the cos function. Okay. Similarly, on the opposite side, you can see that the delta y it is slowly increasing, and it reaches a maximum value here, and again it delta y decreases. Okay. So delta y decreases. Just track the delta y, okay, and again it becomes 0 at this point. So it becomes 0, and again delta y it increases and it becomes maximum. So now you can see that cos x is proportional to delta y. So delta y function gives cos x. So that means you can easily visualize. The cos x function using this slope, which is given at the top of the Riemann integration strips. So we can extend this discussion for the cos x also. So if y is equal to cos x, so you know that the differentiation of cos x will be minus sin x, and we can apply this. So this is cos x. So you are finding that this is equal to differentiation of cos x. We are having the cos x function. We are drawing the Riemann integration strips. Now we have to track delta y. Okay. So when we are tracking delta y, we are finding initially delta y is 0, then delta y gradually is increasing. Okay. And it reaches a maximum value here, and after that it is decreasing, and it becomes 0 at this point, and again it is gradually increasing, and it reaches the maximum value here, and again it is decreasing. So you can easily find that delta y is the representative of the dy by dx of cos x, which is nothing but minus sin x function. So that means the delta y is proportional to minus sin x, which can be easily verified visually. Next, we can go for the differentiation of tan x. So I have y is equal to tan x, and we know that differentiation of tan x will be secant square x. And here I am plotting the tan x function, and here you can see that just to track delta y only. So here your delta y is having some particular value. After that, you can find that delta y is increasing steeply, and it goes infinite. After some point, it goes infinite. So the same function is tracked here as secant square x. And similarly on this line also. So from maximum slope, the slope decreases, and you find that the slope becomes low here, and again the slope increases. This is delta y increases, which is nothing but our secant square x function. The same thing can be repeated, and again it is very much useful for visualizing the slope functions. Next, we can go for the differentiation of e power x. So here we can find that this is y is equal to e power x function, and here we are finding that dy by dx will be again e power x, and if we are finding that delta y is proportional to e power x, that means delta y is also exponential, which is substantiated by tracking the delta x. So here you can see the delta x value is increasing, but the increase is very steep, exponential. Okay, so just by tracking delta y above the Riemann integration strips, so we can find out what will be delta y and what will be the differentiation of e power x. And last, we are having the differentiation of ln x. So this is the ln x function, or y is equal to ln x function, and we know that the differentiation of ln x, okay, is 1 by x, and we are plotting the ln x function, and we are finding the slope of ln x function, and we know that dy by dx it is proportional to delta x as per our delta y as per our previous discussion. So here we are finding delta y. So the delta y is maximum. Again, it is decreasing, okay, and gradually it is decreasing, and it is the slope is moving towards 0. So here that is what is good. Okay, so this function is given by x function. So this function is given by x function. Thus, this Riemann integration strips is very much useful for visualizing the differentiation, that it is minimum or maximum. So thus it is immensely useful for all the students for identifying the differentiation function, especially in the Exponential. Thank you.